Hello, this is Mr. Win, and this video is over conics, starting with circles. So a conic is just a intersection of a plane and a double nape cone. It's the cross section. So on the left side are the four basic conics. We have a circle. You get that when you have a horizontal plane that crosses just one of the cones. We also have an ellipse. That's when you get a plane that comes from the side, crossing one cone at a diagonal. An ellipse is also known as the oval. We have a parabola. That's when you get one plane crossing or intersecting one of the cones at a diagonal from the top. Then we have a hyperbola. That's when you have the plane intersecting both cones from the top and bottom. There's also three degenerate conics. We're not going to worry too much about it, but depending how the plane intersects the two, it might only just be at one point, might be at a line, or if it goes right through the middle vertically, it's two intersecting lines. Anyways, there's multiple ways to view conics. We have the pictures from before. We also have the algebraic equation. This is the general form. You do not have to memorize that, but we're going to do a lot of things with that formula later on. And last, we have a third approach, which is using the definition of conics as a locus of points satisfying some geometric property or rule. For example, we know that a circle is all points equidistant from a fixed point, the center. That gave us the standard form equation of a circle, x minus h squared plus y minus k squared equals r squared, where hk is the center and r is the radius. And make sure you know that h and k are opposites. Whatever's inside the parentheses, squared is always the opposite. So first, if they give us the standard form equation of a circle, make sure you can identify the center and radius. So here's the first example, x was 3 squared plus y minus 9 squared equals 5 squared. So this is going to be negative 3, and this is going to be opposite, it's going to be positive 9. So negative 3, positive 9 is the center. And this is r squared, so r is just 5. It's the thing next to the square power. So that's it there. Here's another one. They put this out of order, so be careful. X is going to be opposite of negative 7 is positive 7, then y is going to be positive 2. So positive 7, positive 2 is the center. Then here, they didn't write whatever squared. We have to square root this ourselves. Square root of 100 is 10, so the radius is 10. Alright, do note that the center and the radius are allowed to be fractions, and even radicals. They might have a root there. For example, square root 2. Alright, next, if given the center and radius of a circle, write the equation. So it's backwards. So the center is negative 5, positive 6, and the radius 8. Fill it in. So first, we're going to change negative 5 to positive 5. So that's x plus 5 squared. Then we'll change positive 6 to negative 6. So that's y minus 6 squared. Then r is 8, so you can say 8 squared. Or you can say 64, your choice. Here's another one. Center is 3, 0. Radius is 12. So I'm going to say x minus 3 squared, and then plus, I'll say y minus 0 squared. And then r is 12, so I say 12 squared, or 144, your choice. Now, we don't really say y minus 0 squared. If you do that, you just can say plus y squared. Alright, because the parentheses doesn't matter here. Alright, if given a graph of a circle, be able to write the equation. So kind of like the last one, except we have to pull the center and radius from this picture. So if you look for the middle, it's right here. So that's the negative 1, and the radius from the center to the side, that's 1, 2, 3, 4. So center is negative 1, r is 4. Then you need to change the sign, so it'll be x plus 1 squared, y plus 1 squared equals 16, or 4 squared. Alright, and then if given the equation of a circle, be able to graph it. So again, from the equation, it's all about finding the center and the radius. So it's going to be positive 2 from this, negative 5 from that. And then square root of 4 is going to be 2. So when I graph this, I start at the center. 2, negative 5 is this red dot. Then I did 2 from there, 2 from there, 2 from the center, 2 from the center, and drew my circle. Alright. Last and most important is if given an equation of a circle in general form, be able to convert it into standard form. So here's an example, x squared plus y squared plus 8x plus 10y plus 16. So that's like the general form equals 0. This process does involve knowing how to complete the square, so I have to review that first, and then I'll come back to this. So completing the square is a process that forces something to be a perfect square by adding what is missing. After we do that, we can represent it as x plus some number squared. It is generally used on quadratics in the form ax squared plus bx plus c equals 0. So here are the 3 steps. First is make sure the a is always 1. You don't complete the square unless a is 1. So if you have an equation, you can divide everything by a, both sides. But if you have an expression, meaning not an equation, you must factor out a. You cannot divide by it because that's not a valid math rule unless you have an equation. Alright, once you do that, then you can calculate whatever b is divided by 2 and then square that. And so this is going to be that missing or magic number that completes the square. If you have an equation, add this number to both sides. If you have an expression, add and subtract this number from the same side, from the expression. Last, factor the perfect square. It will always follow the form x plus whatever b over 2 was, and then all squared. Note it keeps the sign of b over 2. So if b was negative, it stays negative. It will be x minus something. If b over 2 is positive, it will be positive. It will be x plus something. Alright, now if b is an odd number or a fraction, the math will involve fractions. So here's 2 examples. Complete the square for each. On this left side, we have an equation. First, a is not 1, it's 2. So I'm going to divide everything by 2. So here's my new equation. X squared minus 4x plus 5 equals 10. Next, I'm going to find b divided by 2 squared. So b is negative 4. I'm going to do over 2 squared. Well, that reduces to negative 2. Then I square that, I get positive 4. Now, because I have an equation, I'm going to add that to both sides. Notice I put a blank space here and here, and then I put that plus 4 plus 4. So what you do to one side, you do both sides. I added 4 to both sides. Then if you look only at these first 3 terms, that is a perfect square. That is x minus 2 squared. Because x minus 2 times x minus 2 would be x squared minus 4x plus 4. Then don't forget that plus 5. Then over here, I combine 10 and 4, get 14. Last, I'm going to move this 5 over by subtracting it. So now I get x minus 2 all squared equals 9. Now, this is actually how you convert from a standard to vertex form if you don't do the AHK method. But we could solve this. We could square both sides and then get a x minus 2 equals positive 3, and then x minus 2 equals negative 3, and then get your 2 values of x. So this is actually used for solving quadratics as well, although I'd rather just move everything over in factor or quadratic formula. Now the second problem, this is an expression. There's no equal sign. So although a is not 1 yet, I have to factor it out as a GCF. I take out 2. What's left would be x squared plus 3x plus 4 on the inside. Now look at b. b is 3. It's odd, so unfortunately that's going to give me a fraction. I'm going to do b over 2, then square that. It doesn't reduce. That's going to be 9 over 4. Then I have to add and subtract this 9 over 4 inside this to the same side because there's not 2 sides of the equation. So that's why I added 2 spaces. I did plus 9 over 4 minus 9 over 4 because that cancels 0. But looking at this, these first 3, the x squared plus 3x plus 9 over 4 in the parentheses, that factors into x plus 3 over 2 squared. Notice like I said, this is always going to be x plus b over 2 squared. It was positive here, it stays positive here. For this one, it was negative here, it stayed negative inside. Then I combine like terms. I did change 4 into 16 over 4. 16 over 4 minus 1 over 4 is 7 over 4. Then last, you should distribute this 2 to both of these to get a 2 times the first parentheses squared plus 7 over 2. And that's it there. Just make sure you know if you're inside a GCF, inside parentheses, answer that number inside the parentheses. So that's how you complete the square. Now I'm going to go back to the problem. Here we have to complete the square twice. First I'm going to rearrange it, put the x's together and the y's together. So I'm going to put x squared plus 8x together and then y squared plus 10y together. And I'm going to move the 16 over. You're allowed to do that, you don't have to. Then for the first 2, for the x's, I'm going to do b, which is 8, divide 2. Square that, well that's really 4. Square that's going to be 16. So notice for the x part, I did this. X squared plus 8x was 16. Then for the y part, the y squared plus 10y, I'm going to do 10 over 2 squared. That's 5 squared, that's 25. So I'm going to add 25 to both sides. So it's y squared plus 10y plus 25. This 16 and 25 did get added to the other side because we have an equation. These first 3 factor into a perfect square. That's going to be x plus 4 squared. And it's a plus sign because this was a positive 4 when I did the b over 2. Then the y squared plus 10y plus 25, that does factor into y plus 5 all squared. And it's positive because this 10 over 2 is positive. Then I combine the terms over here. Negative 16 plus 16 cancels. Then there's 25, so that's 25. And that is my equation in standard form. Notice we now know that the center of the circle is negative 4, negative 5, and the radius is 5. And that's it for the video. Make sure you join the live sessions. I'll do a lot more harder ones for completing the square. Thanks for watching. Bye.